other high energy phosphate bond that we've talked about. High energy phosphate, creatine phosphate. And we'll get to that a little bit more. ATP and the exercising muscle. So obviously, like I've already said, it's where we directly get our energy from. So it's used during exercise. The use increases during exercise. And then rephosphorylation. So understanding how it happens specifically in each of the different energy systems. Yes.
Where is GTP?
So that's going to be in oxidative phosphorylation. And I'm actually going to pull up a diagram, so I'll show it to you at the bottom. But it's a high energy phosphate.
So just to confirm one more time, to rephosphorylate creatine, that's 5 minutes. Anaerobic glycolysis is 24 hours.
Okay, yes. So you don't rephosphorylate glycolysis.
Okay,
You
it just
your
restore it.
glycogen, right.
Okay.
Mm-hmm. So I'll make this point in case you forget, because sometimes I've seen, you aren't the only one, I've seen some people using that term interchangeably. So you only rephosphorylate things that have phosphate. Okay?
Mm-hmm.
Yes.
So basically ATP and creatine phosphate are the only two that are
Right. They're the only two that we have, they get rephosphorylated. They're the only two that we have talked about really so far, except for GTP.
I was going to say, what about GTP?
That one, I will show you. We haven't talked about how it's rephosphorylated because it's not a major phosphate that we've looked at. And you had a second.
Just the anaerobic side of it. You said we restore glycolysis.
Your
glycogen
stores after a full 24 hours.
24 hours. Okay, cool.
If you want to get back to your pre-exercise levels, and that's pending proper nutrition. So if you're not eating a proper diet, if you don't have any carbs after your exercise, you're not going to get back to your normal levels.
And the consistent carbs is for the oxidative phosphorylation side of it, right?
So you use carbs in 2 energy systems.
Right.
Which 2?
The glycolysis.
And?
Oxidative.
Yes.
Yeah. So, okay.
Okay. Role of enzymes. What do enzymes do?
Speed up or limit.
How do they speed up a reaction?
Yeah, catalyze, what she said.
Well, that means the same thing. They reduce the activation energy. So they reduce the amount of energy needed to get the reaction to start. Okay? So they reduce the activation energy. And explain how ATP is resynthesized. So this is where I'm going to call on you all for some help. I need 3 volunteers.
Oh, look at me.
Okay. So I need one person to just list the major characteristics of creatine phosphate energy. We'll help you if you forget anything. Okay? And then I'll have someone else do.
Somebody already getting up?
I have one volunteer for creatine phosphate.
Somebody getting up? Okay. All right.
yeah.
Okay. So you can go ahead and come and do that one. I need one for anaerobic glycolysis and one for oxidative phosphorylation. Okay.
Do not look over here.
I hope you remember.
Anybody else?
Here you
I'm
go.
honest.
Luckily, I only have 2 markers right now, so only 2 people at a time. You can do. Okay. So we'll let them write it all out, and then if we have to fill in any gaps, we're going to let them know. Well, I'll let the class know.
Okay.
There you go. Yeah, you can help her out. What else?
Oh, we can help. Oh, okay.
Let's start with just this one. We'll do creatine phosphate
I have
first.
this right. Yeah. Okay. So high intensity, remember we have to like recall the exercises. So it would be like explosive.
Power,
Yeah, power.
Is one of the is one of the characteristics? It wouldn't be like fast twitch. That wouldn't be. No, that's not the energy. That's the muscles.
They do have a tendency to.
Wait, no, this depletion. Depletion is associated with fatigue, right? Okay.
How many ATPs?
One per.
She put that up there.
No. So
One per creatine phosphate, right?